Welcome everybody. We got an interesting question. Foremost, we need to have a quadrant. So let me draw that. Okay. So this would be the radius. Okay, all right. So this is taken as O. I'm going to take this point as A, this point as B. Now we have another information. Okay, so let me also include that information. Now there is a line that is hitting from B to A, and then we have a line that is splitting. Okay, AB. So we have this distance to be as 12 units, this distance as 3 units. I'm going to take this point as some P, this point as some Q, and we are asked to find the radius of the quarter circle. Okay. Now, foremost, what we can do is we can identify the regions that are known to us. Now, clearly this angle is going to be 90. Now, if this angle is 90, then this angle has to be 45. This angle has to be 45. Okay. Now, PQ is actually a horizontal line dividing AB. Now clearly I know this has to be 90. If this is 90, then this is 45. Now since angle at, let me take this as capital R. Since angle at capital R is 45 degrees, which in turn is also equal to angle at B, this means triangle BPR is isosceles. So this in turn would mean PR will be equal to PB. PR is 12, PB will also be 12. If I were to take this entire distance as small r, then this distance OP is going to be smaller negative 12. Smaller negative 12. Fair enough. Okay. So that is got. And since OB is equal to R, this means OA is equal to R. So this will also be equal to R. So much so for that. So now we will have to figure out how exactly we can apply Pythagoras. Okay. Now, since this is a quarter circle, any chord drawn from O to the circumference will represent the radii of the quarter circle or of the circle. So I'm going to connect this from O to Q. So as I mentioned to you, clearly this is going to be R units. And clearly this is going to be 90 degrees. So what I would do is I would consider triangle OPQ, since it is right angled, I will use Pythagoras. We can use Pythagoras. By Pythagoras theorem, we know that what? OP squared plus PQ squared is equal to OQ squared. Now OP squared is R negative 12 the whole squared. PQ is this length. This is 12 units, this is 3 units. So that's going to be 15 units. So 15 squared is equal to OQ. OQ is what? OQ is R. So it's going to be R squared. Now what we will do is we will push this to the other side and rewrite this as 15 squared is equal to R squared negative of R negative 12 the whole squared. So this in turn would mean, expand this, right? So negative positive goes off. So you have 24R is equal to 225 plus 144. This is what we've got. So 225 added with 144 is going to give me 369. So 369 is equal to 24R. Therefore R is equal to 369 divided by 24. Now 3 divides here 8 times, 3 divides here once, 3 divides here 2 times, 3 divides here 3 times. So it's 123 divided by 8. So R is equal to 123 divided by 8. What I wish to do is I would like to divide this 123 by 8. 8 ones are 8. You carry, bring the 4 down, you have 3. 8 5s are 40 and you have 3 remainder. Okay. So R is equal to 15 3 over 8 units. So that is the solution for this particular question. If you want to give it in decimal, you can still further go on. So you place a decimal point here, you add a 0. 8 4s are 8 3s are 24. You get a 6 there, and you add a 0 there, and then 7 8s are 56. 4, you add a 0 there, and 5. So you can rewrite this, or this is R is equal to 15.375. If they are asking you to bring it down to after the decimal 2-digit specification, then you can rewrite this as R is equal to 15.38 units. Okay, so that's the solution for this question. We move on to the next one.